All right, good morning again. Welcome to the second ACT Math Prep and Strategies. We've got some new problems that Coach Beard has worked out for you. I want to just take a minute and go back over some of the strategies that we talked about the first time that we went over math. Again, you have 60 minutes to complete 60 different questions or problems. Obviously, that's one question per minute. There are multiple choice questions, and you have 5 choices per question in the math section. You can use calculators, but remember, you do not have to have a calculator to solve the problems. I think some you'll be wise to use a calculator, others probably not. So you'll have to use your best judgment and decide when to use a calculator and when not to use it. A key strategy to remember: work the problems that you know first. Skip those that you're unsure of and return to those problems if you have time. And make sure that you read the instructions. Another reminder: you'll have some standalone questions and you'll have some questions that are linked to the same graph or table. If you look at the example there, you see use the following information to answer questions 33 through 35. And so you would have 3 questions related to that graph. Key point: the math section gets more difficult as you go. The first 20 questions are relatively easy. The second 20 are medium in difficulty. And the third set of 20 are the most difficult. That's why it is so important for you to manage your time wisely in this math section. We talked about this the first time we discussed math, and I'll tell you again that the first 40 are going to be critical in you scoring well in the math section. In that first 40, leave those problems blank. If you feel like it's going to take you longer than a minute to complete it, and come back to those. Don't totally just disregard that the third set of 20, 41 through 60. Don't disregard those problems. You can get probably a lot of those correct as well, but know that 1 through 40 are going to be the easier problems, and don't get caught up trying to solve a problem taking 2 to 3 minutes or longer that you may not get right to begin with. Skip those. When you have a minute left, and let's say you have 10 or more blank, with a minute left, you need to select one answer choice for the ones that you have blank and fill that one answer choice in for your blank problems. Don't do that with 5 minutes left. With 5 minutes left, you can still answer 4 or 5 or more problems thinking through them. But with a minute left is when you need to look at how many you have blank and start filling in blank bubbles, because leaving anything blank on the ACT is not good. So make sure that you complete every problem or have an answer for every question or problem. Again, just make sure that you spend time on the ones that you feel like you can get right, answer all the questions. If you leave one blank, you have a 0% chance of getting it correct. If you guess at it, you at least have a 20% chance of getting that problem correct.
All right, guys, Coach Beard here back with you one more time for the final prep with ACT math section before the big day next Wednesday. Talked last week about a lot of strategies, particularly about the time management that you have to have in the math section with 60 problems in 60 minutes. So you know all those things. So this week we're just going to hop right at it. Go through 5 questions from the middle 2/3 of the problems, from between problems 20 and 40. So if you've got your book, your Case 21 booklet, I'm on page 4 of the math section, starting with number 22. All right, 22 reads, if m, n, and p are positive integers such that p to the n power equals x and p to the m power equals y, which expression represents x, y? This is what I call a theory question. And what I mean by that is there's not actual numbers there. It's just theoretically what would happen here. So the way that I always like to attack those is, can we just come up with a simple example? All right, so they're just saying 3 positive integers. Now, I'm not picking anything crazy. Obviously, with it being positive, it's got to be bigger than 0. Integer is a whole number. But let's not pick anything like 50 or 100, anything crazy. All right, I'm going to pick something very simple and easy to work with. In fact, I'm going to let P equal 2. I'm going to let M equal 3 and N equal 5. Okay, so if we go with what they say in P to the N power equals X, that would be 2 to the 5th power. That's our X value. 2 to the 5th, 2 times itself 5 times. That gives me 32. All right, follow the same thing for P to the N power, P to the M this time. That would be 2 raised to the 3rd, or 2 cubed. That's our Y value, and that's 8. Now, they're asking, what is X times Y? 8 times 32, XY, that gives us 256. Okay, now from there, and I'm not going to take the time to do it, from there you would take those same 3 numbers here that we came up with in theory, plug them into each of the 5 answer choices, and see which one spits out 256. And I'll go ahead and tell you it's answer choice E. And that's the same thing, 256, as if I plug in P was 2, M was 3, N was 5, so 3 plus 5 is 8. 2 to the 8th is also 256. So plug in a simple example, 3 very, very basic numbers, easy to work with, particularly with your calculator, and then plug in the answer choice and figure out which one matches. Now, all that being said, if you have a little bit of knowledge of exponent rules, we can come to this answer much, much quicker and much simpler. Because all they're saying when they say X times Y is take these 2 things here. Take P to the M, take P to the N, and then multiply them. Okay, so if we know through exponent rules that that's the product rule, and the product rule very simply states when you're multiplying 2 things with exponents, then all you have to do is copy their base, so P, and then add the exponents, M plus N. With knowing that, that takes me straight to answer choice E. So whether you have that knowledge or not, you can plug in things and get it to work out, or hopefully we all know the product rule. Maybe can get to it a little bit quicker and save some time. But at any rate, there's E for the first one. All right, on to number 23. 23, the math is really simple. All right, all I'm doing here is the distributive property. So I'm just taking that negative 2y and multiplying it through all 3 parts there inside the parentheses. Well, that gives me negative 2xy minus 6y squared plus 4xy. And if you'll notice, we have a pair of like terms there that both include the xy, and I can combine those, and that leaves me negative 6y squared, had nothing to go with, but negative 2 and 4, that makes positive 2xy. And that's what we're looking for. Now, I said the math was easy. Hopefully that wasn't too bad, just distributing, combine some like terms. What makes this more challenging is that none of the 5 answer choices match that. Right? One of those is equivalent. They just didn't write it the same way we did. So we're going to have to now take the time and go through all 5 of these answer choices, distribute them out, get them the way that we wrote our answer, and see does it match. Okay, so for A, that would be negative 6xy minus 6y squared. All right, got the negative 6y squared part, but negative 6xy doesn't match our 2xy. That's out. B's already been multiplied out for us. Again, it's the same answer that we got here, just already written out, so we know that's not right. All right, C, no work there. 2xy minus 6y, that's close. Our y just included the exponent of 2, so that's not out, or that's not it. All right, look at D. If I distribute here, that gives me 6y squared and minus 2xy. It's close. It's the right numbers. The signs just aren't right. They're backwards. So that's out. Leaves us with answer choice D. If I distribute that, 2xy minus 6y squared. Now, they wrote theirs differently than us. We put the 2xy last and negative 6y squared first. It doesn't matter. As long as the signs stay consistent, it's the same thing. So easy math, hopefully. Took some time, though, to go through and work out all 5 answer choices, but we land with answer choice E again. All right, 25 says, consider the profit function for selling n items. We see P of n equals negative n squared plus 250n minus 25,000. Question is, for what number of items sold will the profit be at its maximum? Keyword right there. So 2 things you should put together. We have a quadratic function because of the exponent of 2. We're looking for a maximum. All right, so if I think about a picture, it would look like this because the a value is negative. Maximum points up at the top. Where does that occur? All right, now I don't have a calculator on the screen. I'm not going to pull up Desmos. I don't even know if you have Desmos on the ACT. I know you do on the final exams. But without a calculator, what would this look like? Now, obviously, you can type it in. You can find the maximum using your TI-84. If you don't know how to do that, come down to 315 and see me. I'll show you in about 10 seconds. It doesn't take very long. But this gives us a good opportunity to talk about how do we find a vertex, in this case a maximum, by hand. There's a simple formula. It kind of gets overlooked because we've got so much with technology now. But the opposite of b over 2a leads me straight to the answer right here. And that letters a and b comes from standard form of a quadratic, ax squared plus bx plus c. So I'm plugging into that formula with numbers from our function, and it should lead us right to the answer. So our b value, the bx term, is 250. It says the opposite of that, so negative 250, over 2 times a. Our a value there is negative 1. Even though the 1's not there, it's understood to be a 1. So negative 1. 2 times that would be negative 2. And negative 250 divided by negative 2, negative divided by negative is positive. 250 divided by 2 is 125. So there we go. 125 items maximizes their profit. Now, if the question asked, what is that profit? Then, of course, we just plug 125 back into the function everywhere we see an n and get that answer there. But 125, simple little formula. Again, hopefully you know how to find a vertex on your calculator, and maybe you even have Desmos. I don't know, next Wednesday. All right, 28 says the solution to a quadratic equation is plus or minus the square root of negative 4 minus 3. Which of the following also represents the solution? In other words, they're saying one of these is equivalent, saying the same thing. They've just written it differently. Now, hopefully, and those of you in Math 2 and beyond, which all juniors should be, you've seen imaginary numbers. And if you notice, answer choices A, B, and C include that I for imaginary. And that, of course, comes from taking the square root of a negative. It's impossible with real numbers just take the square root of a negative number. So that's where the imaginary part comes in. So if we can rewrite this square root of negative 4 with imaginaries, not square root of a negative, we should come straight to our answer. So how do we do that? Square root of negative 4. Well, very simple. All we're going to do is take out the negative. So negative 1 and then the square root of 4. Now, the square root of 4, that's a perfect square. Of course, that's 2 times 2. And then the square root of negative 1, by definition, that is I. That's an imaginary number. So 2i is how we write that. So if I go back to the very original up here and I replace square root of negative 4 with 2i, then what I get is plus or minus 2i minus 3, which is answer choice B. All they wanted you to be able to do there is rewrite square root of a negative as an imaginary number, which hopefully that's not too big of a deal. And you've definitely been exposed to that by now in your junior year. So answer choice B. Last one, number 34. There's actually several problems. I think it was 34 through 39. So you had like 5 or 6 problems with this one situation here. You get some stuff up there, 10% off purchases up to 50, 50%, 15% off purchases over $50. Talking about building a garden. And we get some information in the paragraph, and then the question we're going to work here, 34, is actually really simple, as long as I know the volume formula. So it reads, Anna has built a frame for a raised bed garden and needs to fill it with soil. The last time she was at the garden store, Anna noted that a bag of garden soil was $7.50. Anna's raised bed frame is in the shape of a rectangle with dimensions of 4 feet by 8 feet by 18 inches in depth. What is the total volume of the soil that the frame can hold? Now, 2 things, okay? First off, hopefully, then they don't give it, which means they expect us to know it. The volume formula of a rectangle, volume equals length times width times height. Area is length times width. Volume just adds that third dimension, and we include the height. Next thing you should notice, hopefully, is that our units of measurement there change. We go 4 feet by 8 feet by 18 inches. So I cannot just multiply 4 times 8 times 18, because I have to have the same units here. So that's slightly tricky. Hopefully they didn't sneak that by you in the Case 21 test, and you can handle that. So the first thing is how many feet is 18 inches, right? Or how many inches is 4 feet and 8 feet? It's easier, since the answer choices are in terms of feet, to turn 18 inches into feet, divide it by 12 inches in a foot, and that's 1.5. So knowing that, I go straight to our formula. Volume equals 4 feet by 8 feet by 1.5 feet deep. And when you multiply that and choose your calculator, 4 times 8 times 1.5, that gives us 48 cubic feet. One thing I want to just mention, because they're trying to trick you. We talked about units. If you multiply 4 times 8 times 18 without converting your units, that's 576, answer choice E. So they put that on there, but you got to convert your units to get 48, answer choice B. So hopefully that's 5. I know they were in that middle section, so difficulty ramped up a little bit. Hopefully not too bad. Definitely things I think we should be able to handle. So hopefully those weren't too bad. If you got any questions, like I said, come see me. And best of luck next Wednesday. Go in there and do a good job like we all know that you can.